In this video, we're going to begin talking about rational expressions. Now, a rational expression is one that can be written in the form P over Q, where both P and Q are polynomials, right? So all three of these are rational expressions because you look at the top of the fraction, those are all valid polynomials, and the same thing with the bottom of the fraction. In this video, the main thing we're going to learn how to do is to simplify rational expressions. So since expressions are essentially fractions, then we need to think about the types of things that we would do with fractions. And one of the things was we would simplify them, right? Write them in lowest terms. Now, a lot of times, if you saw something like 8 over 12, the way in which you would simplify it would be to say, let's identify the common factor on top and bottom, and then let's divide by that, and then that will give us our reduced fraction. And that's absolutely correct. But we're just going to take that same idea and show it a little bit differently. And so, still identifying that 4 is the greatest common factor of 8 and 12, rather than writing divide by 4 like this, we're going to go ahead and write 8 as 2 times 4, and 12 as 3 times 4. And the virtue of that is then I can look at it more of as a cancellation type thing, right? I have a 4 on top and a 4 on bottom that I'm multiplying by the other factor. And so I can cross those 4s out, leaving me with only 2 over 3. And that is the principle that we're going to use to simplify rational expressions. Factor, right? And the important part here is from there to there, we factored the top and the bottom. Okay. So in these examples here, we're going to simplify 4x squared plus 4 over 4. So I can't even think about trying to reduce anything until I have the top and the bottom factored. Okay. Now, in this first example, the bottom one, there's nothing to do, right? So it's just going to leave that as a 4, but I ask, how can I factor the top? Well, we always think about easy factoring, right? There is a common factor of 4 in both terms, and so I can pull those outside of parentheses. And now that I've factored the top, now it's okay for me to go ahead and cross this 4 out on top and cross this 4 out on bottom. Of course, when I do that, you're really dividing by 4, and so there's a 1 there. But in my final answer, you don't need to put the 1, right? So our simplified version of that rational expression would just be x squared plus 1. In the second one here, there's only a single term on top, so no factoring necessary there. But with these two terms, I want to look and see, is there something I can factor out of both terms? Numerically, I can factor a 3 out, and in terms of variables, I can factor a y cubed out. So 3 times 2 is 6, and y cubed times y is y to the fourth, and then minus 1. And again, now that I've got it in factored form, now it's okay for me to cross out the 3's, cross out the y cubes. And of course, this is really important here because it's up on top. You need to understand there is a 1 here, right? After you've divided on top and bottom, if everything gets crossed out, there's really a 1 left over. So my final answer is 1 over 2y minus 1. So the example here on the left is an interesting one. The top is already factored, okay? But since I'm in the habit of trying to cross factors out on top and bottom, um, what you might find helpful is to write it like this: x plus 5 times x plus 5. I'm not writing it like that because for any purpose other than if I can maybe factor out, if I can cancel out one of those x plus 5s with something on bottom, it's just easy to see. when I can actually slash one of them out up on top. On the bottom, does that factor? Well, nothing factors out of every term, but as we learned earlier, that's a difference of squares. So it factors into x plus 5 times x minus 5, not x, excuse me. X plus 5, x minus 5. And since there is a common factor on top and bottom, this x plus 5 and this x plus 5 can cancel. And as similar as this one and this one look, they both have x's, they both have 5s. They are not identical. They have to be identical factors in order to be able to cancel out. So x plus 5 over x minus 5 is my final answer. All right. Please understand, I'm not going to write this on here because I'm reluctant to put anything incorrect kind of in ink on our slide. However, you cannot cross these 5s out. You cannot cross these x's out with one another because they are not factors, right? They are terms. They are being separated from the other things in the top and bottom of their fraction by addition and subtraction. You cannot cross things out when they are being added or subtracted with other stuff in the part of the fraction that they're in. It's only when you have multiplication, right? Remember, factor means you're multiplying things, right? It's only when you have multiplication that then you can cross stuff out of both the top and bottom. The example on the right's another interesting one. You might look at it and say, boy, the top and the bottom really look similar, right? And they do. They both have 2's, they both have x's. Okay. Sometimes they're only off from one another by a negative. To tell if that's the case, one suggestion I might have is to start by writing them in the same order, right? If you have x on top, x first on top and 2 second, maybe go ahead and put x first and 2 second on the bottom. Just make sure when you rearrange it, you keep the symbol that's in front of the x with it and the symbol with the 2, which would be positive, with it. Now, when you look at this, you can say, okay, what happens if I factor out a negative? Okay, which literally means let's take a negative outside, and you're really taking a negative 1 out. And we need to get this back. So negative 1 times positive x would give me negative x, and negative 1 times minus 2 would give me plus 2. Now I do have the bottom factored. I have x minus 2 is the only thing on top. So I actually can cancel this out on top and on bottom. What I'm left with is a 1 on top and a 1 on bottom when I do that cancellation, right? But I have 1 over negative 1, which of course gives me a final answer of negative 1. Okay. Let's just make a note that this is a different scenario than this one. If I were to factor a negative out of the bottom here, it would not match up. Okay. I'm just going to write this in different color down here separately. If I had x minus 5 and I decided to try to pull a negative out of it, I would have to have a negative x, right? Because a negative times negative is positive x, and a plus 5. And that is not the same thing as the top, right? So that's why I didn't take this one any further, and it was done at that point. All right, and then of course we can simplify rational expressions when the factoring we have to do is kind of the harder type of factoring that we worked on previously when we learned about how to factor trinomials. So the good news is the situation does become a little bit easier once you get either the top or the bottom factored. So let me demonstrate this. Let's say on top, I'm looking to factor what I have there. Nothing can come out of every term. Okay. And while I could use the AC method for something like this, there's only one way for 5x squared to break down, right? And then also we're limited on how the plus one can break down. The only way it can work is if I do -1 and -1, right? So this is a good one for just go ahead and guess and check, and we know we did it right because inside is -x, outside is -5x. Those add to make my middle term. All right, so here's where um, things can become a little bit easier. All right, you know you're going to have a 3x here and an x here. There's a couple different ways to, take -7 and place them in these two slots. But what you can do is say this, the only way that I'm going to be able to simplify, or in other words, the only way I care if this factors, is if one of these two factors can cancel out with something that's on the top. Well, since neither of these have a 5x, nothing's going to cancel out with 5x minus 1. So my only hope is that maybe I can cancel this x minus 1 out. Well, because that's my only hope, then what I can do is I can lightly pencil -1 in here with the understanding that it's not a guarantee that this is how it's going to factor, but if it doesn't factor this way, I don't really care. Like my final answer would just be the original because I wouldn't be able to reduce it. But thinking ahead and saying, well, my guess is that maybe something cancels. So I'm going to go ahead and put -1 here, which would mean +7 would have to go right there. So the nice thing about when you're reducing rational expressions is that sometimes you can not necessarily try all the possibilities, right? You can just try, um, you can try the ones that will make it so stuff will cancel. And if those don't work, then you can just say, well, it was already simplified and that's my answer. But clearly x minus 1 does work here to cancel on top and bottom. So I'm going to cross that out and cross that out. So my final answer here is 5x minus 1 over 3x plus 7. Okay, now we want to look at this one. Here, we want to definitely not forget about our easy factoring, right? So on the top, I can see a 3 can come out of both of those terms. And I can see a 3 can also come out of those terms. Okay. Now, you have a couple of options here. One is you could just factor both the top and the bottom as you see them. Um, but another option is if you're going to factor the top here, a lot of times it's nice to have the x squared term be positive. So if you wanted to pull a -1 out of the top here right away, that would be okay to do. So like I did on the previous slide, we can rearrange here so the x squared comes first. And then go ahead and factor a negative out. So we have a positive x squared term. But then I'm thinking both of these can factor in the reverse FOIL sense. So x squared minus 1 becomes x plus 1, x minus 1. And x plus 2, x minus 1. So now we can have everything completely factored. So we can see these 3's going away. We can see these x minus 1's going away. And so our final answer here We have a negative, but then let's just keep the parentheses, right? Because this negative has to apply to both of these terms. Negative quantity x plus 1 over x plus 2. All right, this would be a great one to try on your own. Press pause, uh, make sure it's completely factored, and see what you can cancel from the top and bottom. And then press play and see how if we got to the same thing. Okay, so I can see that on top, I can do a little bit of easy factoring. I could pull an X out of everything. Okay. Now on both the top and bottom, I have quadratics that might not be the easiest to factor. And so don't hesitate to go back to, your AC method if you'd like, or guess and check. Um, Either one of those is fine. Because I have a 2x squared and it breaks down as x and 2x if it does, in fact, factor, I'm just going to go ahead and pencil those in and then just do a little bit of guess and check. And so remember with guess and check, we're saying um, let's think of the ways that -6 could break down. 1 and 6 and 2 and 3, and we could have, negatives there and there, or we could have -1, 6, -2 and 3, right? And so we can go ahead and plug stuff in and see what we get. I'm thinking I'm going to try doing a -2 and a +3. When I check that, right, -4x plus 3x. Yes, that does in fact give me -x. So I know I did that correctly. You could absolutely use the AC method here. That would be a great idea. But you end up with that factorization. Okay. Now here's where on the bottom, you can use what's on top to help a little bit. And so you can say, well, I'm trying to create a +6, so they both have to have the same sign, but there's a negative middle term, so they both have to be minus. So I'm kind of thinking my only hope of canceling is with this -2. So I'm going to try to see if -2 would work. If I put -2 here, that would mean -3 would have to go there to make that +6. Check the outside and the inside, and they do add to make -7. So I know I've done it correctly. Now that everything is completely factored, I can cancel out these x -2's. So I get x times 2x plus 3 over 2x minus 3 as my final answer. It's worth noting that if you have something like this, if you want to multiply the x through to both terms, that's fine, right? But you don't have to. You can just leave it like this as well as a final answer. As long as you've canceled everything that can cancel on top and bottom, you're good to go.